so, of course, last time we were talking about strings, but I want to take a chance to take a step back, because at this stage, you know, we're learning computer science. Computer science is this giant umbrella, okay? And there's a lot of things that fall under this umbrella, like programming is one of the things, but programming is not, isn't everything about computer science. There's a lot more. There's engineering aspects of it. There are also, like, abstract aspects of it that we can talk about way later. But at this stage, you might kind of not, how do I word this? There's a huge disconnect between the code you write and what's happening physically on those computing machines to get the job done, right? Okay, you write code and you hit run and it works, but at the end of the day, that box is still kind of doing some magic, right? So when you start learning computer science, you start learning to code, you know, we start up here writing code, when in reality, way down here, there's a lot of like physical things taking place on those computing machines you use to compute stuff. And if you have no interest in how those machines work, that's fine. It doesn't really matter, I suppose, because, I mean, technically computation should be not dependent on, like, the ability to do something useful with computation is not dependent on the computational system. Anyways, I'm going on and on and on. But what I wanted to show you is that some of the concepts we've been learning so far are very easily implemented physically. Of course, okay, we learned about Boolean values. Okay, Booleans might be the easier thing to demonstrate, because a Boolean only has two values, right? True or false. 0 or 1. 1 is true, 0 false. But, you know, obviously the computer, like there aren't zeros and ones flowing through the computer really. It's low voltages and high voltages, right? Sometimes there's like power and sometimes there's no power. So when there is power, that's 1, that's on, that's true. And when there is no power, that's 0, that's false, that's off. Do you get the idea? So voltage is there, true. Voltage isn't there, false. And we've got all these zeros and ones taking place, right? So, what I built here is two little circuits. How well can you see? Like, you don't really need to see the components because I do have some lights that are going to go off. I've got two circuits here. The one on the right is AND. I built an AND circuit. And the one on the left is OR. And for those of you who are watching it on YouTube, I'll bring it up to the camera in a moment, because I know you can't see this. But it's really compact, so it's going to be hard to see. And I've got two little buttons here. Do you see? And I've got two buttons here, of course. When the button is not pressed, there's no current flowing through there. There's no, it's a 0, okay? But look what happens if I turn it on. Oh, come on. There, right? You can see the red light turn on. So that means true now. When the light's on, that's true. That means there's a 1 there. There's high voltage. So if I push this, it's true. I can push this, and that turns on too. But look at this green light here. Okay, it's not on right now, obviously. It's not on now. Not on now. But let's see what happens if I push both buttons to let... Whoop, let's see. There we go. So now, when they're both on, we get the light showing up. So when they're both on, I mean, that's AND, right? So we did the AND operation we've been talking about in code physically, really simply. And it's these ideas that are implemented on those boxes you've got in front of you. And over here I have OR. All I have to do is turn one of them on. For the thing to turn on, and if I push both of them, it doesn't really matter. It's still on. It's kind of neat, right? How these ideas we've been talking about at a very high level in terms of Python programming, true and true, a statement that's true and a statement that's true returns true, right? Well, we just did that with this little circuit here. And let's see if I can kind of show this to the screen. I don't know how well this will go. I might end up shorting up my circuit real bad, I don't know. But let's have a look. Oop. I'm going to turn this off now. I'm going to switch this over to that. How the heck do I turn this off? Alright, well that's weird. Anyways, let's see if I can show this on the camera. Okay. So, I don't know if the wire's long enough. Okay, here we go. Here we go. Here we go. Here we go. So I've got these two very simple little circuits. This one over here is AND, so now it's the one on the left is AND, the one on the right is OR. And of course, with AND, we hit one of these buttons to turn on, so that's like a 1 or a true. Here is the other one. But if we push only one, the green light is lit. So it's hard to do because it's so small, but you'll see that once I push both of them, the green light turns on. And similarly with AND, but only one of them needs to be on. On. And if we push both, which I'm not sure I can do, it doesn't really matter, it's still on. So isn't that cool? You get a chance to actually see that although we're talking at a fairly high level, at the end of the day, it's still not maybe as disconnected as you might think. I mean, don't get me wrong, there's a lot going on. You'll take courses on how all this stuff comes together. But very simply, we can see how we can do just AND and OR really nicely. Okay, unplug this. I wish I could figure out how to turn this off. Do I have to go back to the document camera, then turn it off? I guess that's nope. All right, whatever. I'll just lecture with this extra little light on, I suppose. Any questions before we get started, though? Because last time we were talking about strings, and we saw how they were a little bit different. So, if we're interested in playing around a little bit, if I ask for A at 0, it'll give me the thing at the 0th index, which of course is H, because it's the H in hello. I put in the 1, we get the E. And I can ask the length of the string, and it just tells me how long it is. And we did see that funny thing about how the length, the last index is the length minus 1. Yeah?
You put it at, like, I guess it would be space. Would it just show up blank, the space?
Let's try it. Interesting, right? I mean, it is. I mean, a space is like like part of that string, right? So I guess we better get that as a character. Other questions? That was a good one. Okay, so we were playing around a little bit. So a string is a collection of characters. In other programming languages, not Python, asterisk. In many other programming languages, individual characters are their own type. And then if you want strings, you need to have many of these characters. Okay? Now in Python, it doesn't really distinguish between the character and the string typically. So that doesn't really matter, I suppose. But anyways, it's a collection of these little characters, or substrings that are one character long. And while we saw that it has a type, we also know that an empty string is still a string, right? You remember that? I'll show you again, just to be sure. I can do something like this. B equals open, close, print, B. So it prints out nothing. It's a string, but it has length 0. So empty strings are still a thing, not to be confused with none. Remember, none is literally nothing. Where this, no, it's a string, there's just nothing in it. So it's a collection of these smaller things. And we can start talking about this concept of objects now. But I mean, we're going to take some time to really sink our teeth into the idea of objects, and you're going to spend this semester and most of next semester, most of the beginning of next semester, learning and playing a lot with objects. But we're going to go in slowly. We're going to tiptoe into the shallow end. So, anyways, let's do an activity. Yeah, write a single line command to print the first 4 characters of some arbitrary string you make. So I made my A hello world, you can do that too. Yeah, or you can use whatever string you want, but I want you to write something that'll give you the first 4. I'll give you a minute. And there's a couple other steps as well. Well, whatever. Who here did something like this? Raise your hand. Yeah. I mean, you didn't need to use the commas. I guess you could have just like concatenated these substrings together, and then we wouldn't have the space. There, great. So, I mean, that clearly works. And then like the second to the seventh, well, okay, so the second, I guess the second, what do we mean? Do we mean the second meaning the thing at index 2, or the second meaning the second one? Oh, you know what? I didn't make this clear, so I guess you can go either way. It doesn't really matter. Let's just be lazy. 2, 3, 4, 5, 6. I wasn't really clear about my edge cases, so it doesn't matter too much. Point is, we can do stuff like this. Anyone figure out the last part? Raise your hand if you did. How about the last 3 characters? Well, there's a couple of ways we can do this. You know, the good old-fashioned way might be something like this. Length of A minus 1, because we know length of A minus 1 is always the last index. Remember that. Because hello world, how many characters are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. But there is no such thing as index 13. There's index 12. Because it goes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the last index is the length minus 1 always. And I can just kind of do the same idea, except do minus 2. Minus 3. LD exclamation point, great. And if you did it in the other order, it doesn't, I guess it doesn't matter. Like it came at exclamation point, DL, it doesn't really matter. But there, great. Now there's another thing we can do in Python. Not many programming languages let you do this. But we're actually allowed to do this. Index negatively. Index -1 is the last character. So Python actually makes it really handy to, you know, go to the end, start counting backwards. Now, here's a quick one for you. Anyone do it this way? Maybe you should do that, I don't know. Anyone do it that way? Is it because you looked ahead? Yep. It's because, wait, where did it say? What does it do? So you cheated. That's it. So what this is called is slicing. So this is a way to say, give me 0 through 4. So it gives you back like that subset. We can do 2 to 4. Does that check out? 0, 1, okay, so this is 2, 3, But does it include the 4th symbol? No. What were you going to say?
No, I'm saying it doesn't.
Yeah, it just doesn't. So this is the interesting thing about slicing, is it's inclusive on the low end. So if I put in 2, it's going to pick that 2. It's going to start at index 2. But then it's excluding the right end. So it means start at 2 and go up 2, but don't include 4. That's how it works. Why? Because someone somewhere said that's how it works. But you can also imagine, I might do something like this. And it'll still work nice and handy. Where if it went up to and including that last value, it would have tried to go to index 13, which of course does not exist, right? So, okay. What's cool about slicing is we can do like -1 to, or -3 to the end. What's cool about slicing as well is if you don't put something on one of the two sides, it assumes the beginning or the end. So I said -3 to colon nothing. Well, that means go from the third last to the end. I could do this to -3. Just go all the way, there we go. Start at the beginning and go all the way up to the third last. Don't worry about memorizing slicing at this stage. If anything, it's just like the shorthand to make your life slightly easier in Python. Not many programming languages have it. If you hate this, go ahead, never use it. Doesn't matter. It's just a cool thing to note, and you'll learn this with practice. Okay. All right. We can get the length of a string. We already talked about this, right? If I say length of A, it'll tell me what its length is. I guess in my case, A was 15. So, can you then, if we can get the length of a string, here's the test for you. I'm going to give you a couple minutes to work on this one because this is non-trivial. You should be able to get it. If not, that's okay. But you've got all the tools in your tool belt. Knowing that we can get the length of a string, and we can store that value in a variable, of course, like anything else. If we can get the length of the string, can you write a function that will take some arbitrary string, I guess here I called it A, some arbitrary string, and then, what does it say? It uses a while loop to print each character on its own line. See sample output below. Notice that the underscores are just there to like specify spaces. They're not really underscores. So here's your job. Write a function to do this, and this would assume that my little string. What time you got? 39? I'll give you to 143 to try to get it. I believe in you, though. I think you can do it. drop in a couple of hints there if you're stuck. Or maybe this is the bit that you got no problem, I don't know. Raise your hand if you just need 30 more seconds and you're gonna get it. Okay. Keep working on it, but I'm gonna start going through it from the very beginning. So all I've got is the start of my definition of the function, def vert print, and then it takes a variable and I'm calling it inster. So that's the parameter, inster. So it'll take any odd string, whatever. And then I'm getting the length of the string. Now, I guess I didn't need to say this to a variable, but I am for simplicity. And for the number of things. And counter is just my counter, because we know we got to do while loop. And while loops, we've seen while loops with counters before. We've seen while loops with just general conditions, right? But we really did focus on the counting while loops before. So when doing that, we know we needed that counter variable to keep track of how many times we run the loop. So, while something, I'm going to print something, and then I got to increment counter. That's it, right? But of course, these two bits aren't really trivial, I suppose. Well, what's the condition? We've got our counter. We're adding 1 every time we go through the loop. And we know how many characters there are in that string. So if I had 13, let's say we're using that example of my hello world exclamation point. If the length was 13, how many characters do we want to print out? Yell it. I'll ask the question again and I want you to yell. And yes, it's that simple of a question. If your string is length 13, how many characters do you want to print out? 13. That means the loop has to run how many times? 13. Yeah. So let's say my string is length 41. How many times would the loop have to run? 41, of course, right? If the length was n, how many times does the loop have to run? Yell it. N. So I know how long the length is. I know how long the string is. I get the length of it, I store it into n. And I need to do a print for each character. That's the job. So the condition is, I want to run the loop n times. So here's what we do. We've got our counter. Counter less than n. Great. Now you might be wondering, maybe you're not wondering, but maybe you're just observing the fact that, yeah, I started counter at 0. Should it start at 1? Well, I guess it depends. We could make it start at 1, although hopefully after this example you might see why it's kind of good to start at 0. But let's make sure this makes sense, right? Like, if I have 4 characters, if the length of my string is 4, right? Counter starts at 0. Is 0 less than 4? Say true. Okay, so we run it once. Then we add 1. Is 1 less than 4? True. Look alive, people. Is 3 less than 4? Wait, I think I skipped 2. Is 2 less than 4? Is 3 less than 4? Is 4 less than 4? So the loop runs 4 times. So we start at 0, and we go up to, but exclude that last, like the index that would be the length. Because remember, we start counting at 0 when we index things. So it's actually kind of handy to start at 0. Because if we started at 1, let's see what happens. I would have to do less than equal to. Oh. And there's nothing wrong with that here. But the issue comes up as soon as we want to start indexing things. I want to print in str at location what? Actually, I'm going to go back to 0 right now for simplicity. What on earth should that question mark be? Well, that was rhetorical. Who said counter? You're right, but why counter? So every time we want this loop to run, we want to print a different character, or at least the character from the corresponding index in the string. So if I put in 0 here, let's see what happens. Well, I just printed out H. How many times? Did I have a comma in my other example? Yeah, well, whatever. All it's doing is printing out H 13 times. That's clearly not what we want. We want it to print out one of the first H, the 0th H. So we obviously can't put 1 in there. Or pardon me, the 0. We can't just put the 0. I mean, we know the loop is running the right number of times, but every single time that loop runs, it's always printing out inster at location 0. And that's no good. Because we want it to do 0, and then 1, and then 2, and then 3, and so on. But clearly, I'm missing something, right? I know how to index the string. I know how to do the loop. I know how to do the counting. But the issue is, how on earth do I get the right index corresponding with the iteration of the loop? Well, we get really lucky because we get like 2 birds, 1 stone type of a thing, because counter beautifully corresponds with like the indices. The first time that loop runs, what is counter going to be? Yell it. Then the next time, what is counter going to be? Then the next time. Next time. And so on. So we can use counter. Because we want it to start 0, and then 1, and then 2. It's perfect. It's handy. Because counter is just being incremented. So if I do counter, look at that. Looks good. Let's see what happens if I turn it into, like if I start my counter at 1. 1, I would have to do less than or equal to n. Okay, great, run. What letter does it start at? E. We missed that letter, right? Because we started counting at index 1. And in fact, it actually crashes because it tries to get the thing at location n, because we go up to and include n. So in this case, it includes 13, and it's trying to access the string at location 13, and of course that doesn't exist. Now you might say, this is very easily fixable by doing this. -1, right? This will fix it, because the first time through it's going to be a 1, and then what's 1 minus 1? Well, that's 0. The next time it's going to be a 2, 2 minus 1 is 1, and that's what we want. So we do this, it works. But you know what's easier to do this? 0, less than, and just leave it as count. Computer scientists, we love starting at 0. And we love going up to, but excluding things. It's the way it is. Start counting at 0, but remember that 0th time is still a thing. It's not nothing. Any questions about this example? So raise your hand if you had gotten it. Really high, I want to see. Raise your hand if you totally would have got it if you just had a little bit more time. Okay. So, at this stage, this is a perfect place to take pause and take note of how you feel you understand this course. Because assignment 1 was due, assignment 2 has been out for a little while. How many people even noticed that? Okay, well that's good. Yes, it is anyways. What do you do in assignment 2? Who can tell me? You simulate a zombie apocalypse. Pardon? Yes, close enough. Great. At this point, we've learned so many of the basic tools that go in your tool belt for programming. Your loops, your ifs, your variables, your functions. That's a lot of the tools that you're going to be using on a daily basis. That's like the majority of them. The only thing that we're missing at this stage is like lists/arrays, which we're going to learn very soon. But at this stage, if you find yourself struggling, and you can only answer this for yourself, I can't tell you. So I don't know, but you are the one that has to take the initiative here. If you find that you're struggling at all, like if you looked at this and you're like, oh yeah, I could have got it, you're in great shape. Keep up the good work. If you look at this and you're like, yeah, you know, that's typical. That's typical. There's nothing special about that. But if you're looking at this and you're like, whoa, what? That should tell you that you need to go back, slow down, revisit those lectures, come to office hours, go to the tutorials, go through the online textbook, get on it now, because it's going to start ramping up. If there's any questions about anything up until this point, please ask. Yes?
It's not about the course, but can you say anything about the midterms that's next week?
There is no midterm.
Okay, sometimes when the website comes up, it might be like, it comes up with an older version. It's telling us that there's a midterm next week, but then sometimes it's not there.
What?
I can show you, that's okay.
Okay, well, one second. There's no midterm there. What's the URL?
Yeah, just a second.
Is it this? Is it just outline.html?
Probably.
Yeah, don't go there.
Okay.
That'll be last year's. Does it say fall 2019 at the top?
Yeah.
There you go. Don't look at last year's syllabus. Yeah, there was a midterm last year. The reason we're not having a midterm this year is there's a couple of reasons. The complexities of COVID in general, and physical things being passed around and whatnot, and having 2 sections of the class taking place at the same time, but one's online. That would be a nightmare to coordinate, so it wasn't happening. I'll let you know, though, that if you're thinking, oh great, we don't have a midterm, that's actually really not great for you, because the midterm is a chance where you get to really see how well you get this stuff. Assignments are one thing, you know, you talk to people, you figure things out, you got a lot of time. But it's when you're in that test environment that you get a chance, and the tests aren't supposed to be hard. They're supposed to be, if you know what you're doing, easy, easy, easy. If you don't know what you're doing, you're screwed. That's how I design my test. It's not like, oh, if you know what you're doing, it's still a challenge. No, I like to hit that line. Anyway, point being, every other year that I've been teaching, the midterm gives people that feedback that let them know, how am I doing? So this year there's no midterm, and the only opportunity you have is the assignments, which aren't great measurements of how well you understand these things really, and your own feeling and gauging of how you're doing. Yeah?
So on the same topic, it says that the final exam is take home. How does that work?
I don't know yet. I'm going to figure that out later.
Okay, fair enough.
So I can't say it because it's being recorded. So what I'll do at the end of class is maybe I'll answer that question after I stop the recording.
Okay.
Any other questions? So everyone's A-okay and understands everything. So any silence is just apathy. I'll assume that's the case, and I'm going to move on. I'm going to keep going. That did answer your question, of course, right?
Yeah.
Okay. So we did verb print. So while loops are great. While loops are very general purpose. But we've seen another type of loop already, assuming you did assignment 1. Despite never learning them, you were able to use them. All you have to do is poke and prod it, see how it works, and there you go. What's the other kind of loop? Don't look at the screen. A for loop. A for loop. And a for loop is really, really handy. Now I should say for loops in Python are a little bit different than for loops in many other programming languages, but they're very, 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 very similar. At least they can be used very, 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 very similar. But what a for loop means in Python is for each thing in the collection of things, do that. Okay? So, I'm going to show you the quick change here. Oh, and then I guess I have to call. Look at that. I replaced that whole chunk of code, that while loop, with those two measly little lines of code. So the for loop is really handy here. Because all we wanted to do was one thing for each thing in the collection of things. So what does this mean? This means for each C. Now I called this variable C, and listen up because this confuses a lot of people. It does not matter what I call C. It can be whatever I want. It's just any other variable name. Same rules apply, can't start with a number and so on. I'm calling it C because inster is supposed to be type string. So a single thing from that collection, that string, is a character. So that's why I called it C. The number of people that are like, oh, it's got to be called C because it's a character. No. This can be called whatever you want. I can say and it works just fine. So the point is, the one on the left, it's just the variable. But what the for loop means is, for each thing in the collection of things, my collection of things is a string, so it's a collection of characters. So for each character, do this code, print it out, and we store for each iteration of that loop, C will be the corresponding character. Well, now C will be the corresponding character because it's actually called C. So the first time that loop runs, it's H. Why? Because that was the beginning of the string. Then it finishes and goes back to the top, but now C becomes the next character, and so on. So for loops are pretty darn handy. And you're going to be using them a lot. Yeah?
So for strings, it takes each character one at a time. What would it be for other classes? Or can you make it take multiple characters at a time or stuff like that?
Well, so that's no asterisk. But, I mean, there's a lot of like, well, kind of, in general, no. But, so here's the issue at this stage. In lecture, we've only seen one collection of things. Right? Because it's the string. So the string is our first like collection of other things, like strings and their characters, or in Python, strings and their substrings that correspond to individual characters. But also, we did see in assignment 1 the use of a for loop. What was the collection in the for loop? Who can tell me? Bingo. I mean, we can get a little bit more precise. And I'm going to use some jargon that you're not familiar with yet, but you will be by the end of the semester. It was a list of longitude, latitude pairs, right? In fact, it was a longitude, latitude tuples, technically. So the collection was that collection of lat-long pairs. So what I said in that assignment was for each lat-long pair in locations. I guess I should do it backwards because I'm facing you. For each lat-long pair, I think I called it each lock in locations. But lock itself actually had like, it was a tuple. It had 2 values stored in 1 value, so we needed to index that as well. We could have changed assignment 1's loop to a while loop really easily by doing what I did before I had this as a for loop, but with a while loop. Anyways, I suppose we'll wrap up here.